Yesterday what we talked about was the new versions of sine, cosine, and tangent. Secant, cosecant, cotangent. And we sort of expanded the idea of what these trig ratios mean, so it's no longer locked into right triangles, but we can now find the sine, cosine, tangent of angles of rotation, so things that are in the second, third, and fourth quadrant. And the way that we do that is by looking at the x and y coordinates of a point along the terminal side, along with the radius, that is the distance from so let's go over second quadrant. We can look at a point on that terminal side, x and y, where x is obviously the horizontal distance, y is the vertical, and r is the distance from the origin to that point, where we've got angle theta right there. And so you may be wondering, does that point right there have to be at the very end of this line segment? And the answer is no. We could actually pick another another x and y right here. I'll call that, A and B, because if you notice, A will be the horizontal distance, B would be the vertical distance, and then we would have this distance right here, C, and this triangle right here, right triangle, same reference angle right here, so therefore same angle here as what we have up there in the larger triangle. And so this triangle would be similar to that triangle, and so therefore the angle would be the same, and you can just continue that all the way down. So the point doesn't necessarily have to be at the very end of it. It could be anywhere along those lines. But that's what the x and the y and the r represent. So if we look at this problem right here, this I think it's like what we solved yesterday. It says let theta be an angle in quadrant 1, okay, so quadrant 1, such that tangent of theta is 3 over 2. We look at that ratio, so y over x, so the y is corresponding to the 3, the 2 is corresponding to the x. And then we can do Pythagorean theorem to figure out what this side is. It's the square root of the sum of the squares. So 9 plus 4 is 13. So this would be the square root of 13. And then we can go through here and just find cosine and cosecant, no problem. Writing the formula down, cosine of theta, x over r. So 2 over square root of 13. Cosecant theta, r over y. So square root of 13 over 3. Does that look familiar? Sort of using Pythagorean theorem, figuring out what those other values are, or other value. And then just applying our new trig formulas. Okay, so that's not too bad. That's, like I said, that's what we worked on yesterday. That question, I think, is exactly the same, at least very similar. Let's skip down, though, to number 7. Number 7 is a great question. It says, let theta be an angle such that cotangent of theta is 5 pi over 4, and the sine of theta is less than 0. Now, I'm going to temporarily cover up this piece of information right there, just so we can enter into a dilemma. So this says cotangent of theta is 5 over 4. So cotangent of theta is going to give us what ratio? What over what? X over y. So my x is 5 and my y is 4, based just on that information right there. So that's going to be 1, 2, 3, 4, 5 on the x, 1, 2, 3, 4. For the y, okay, no big deal. So I would say that this angle must be in the first quadrant, right?
Yes.
However, that is not completely true, okay? If I tell you that cotangent of theta is 5 over 4, it could be in the first quadrant, but there is another quadrant that it could also be in. Anybody want to make guess which other quadrant that might be?
Third.
3. Might be in the third quadrant. How would that be in the third quadrant? They're both positive.
Both negative.
Well, yeah, but we don't, that's covered up. We don't know that. Okay? They could both be negative. Wait a second. You're saying it could be negative 5, negative 4? Which one is it? And how do you know it could be negative 5 or negative 4? Let me back up a second here. I'll use some other numbers just to make it a little bit different here. So 2 over 3. Let's go ahead and reduce that. What's 2 over 3 reduced to? What's it reduced to? 2 over 3, that's pretty much it. Yep,
I was like, it's smaller than 2.
Right. What about negative 2 over negative 3? What does that reduce to? 2 over 3, okay, great.
Oh, shoot.
So, if I give you 2 over 3, alright, then the question is, where did it start? Did it start with positive over positive, or did it start with negative over negative? I don't know, but they're both legitimate possibilities, right?
Yes.
Okay, so the same thing is going on here, where I'm telling you that the ratio is 5 over 4, but you don't know if that started off as positive 5 over positive 4 or negative 5 over negative 4. Okay? So that is the dilemma. And now I will say, aha. Let's look at that extra piece of information. Sine of theta is less than 0. So now sine of theta is what over what? Y over r must be less than 0. Now yesterday I told you, just sort of a decree, I said something about r. R is always positive, okay? In this context, in these situations, they're always going to be positive. So since I know that r must be positive, but I have this fraction here, which is clearly negative, then what does that tell me about y? Y has to be negative. And so now we're like, okay, so since the y is negative, then that means that this really was a negative 4, and since this whole thing, they both be positive, but they must both be negative, and therefore the x must also be negative. So that tells me, sorry, first quadrant, you're not the right answer. We're looking in a third quadrant solution for our theta. And now we can go and use Pythagorean theorem. 5 squared, 25, plus 4 squared, 16. 25 plus 16 is 41. Take the square root of that. Still square root of 41. There's our x, our y, and our r. So now we can say cosecant of theta equals r over y. So square root of 41 over negative 4. And secant theta, r over x, square root of 41 over negative 5. So the tricky things about these, they don't tell you which quadrant, at least not directly, but they kind of tell you in a sneaky way. Sort of making us think there. Any questions on that problem? All right, let's do one more. I think we can finish with this. So let's see if we can discover the dilemma. First, I'll cover this up. This says sine of theta is equal to negative 5 over 8. Now, we have a decision on what to do with this negative. We can push it to the numerator or we can push it to the denominator. But we know that r is always positive, so therefore we have to push it to the numerator. So we have negative 5 over 8, that's our y over r value. So which quadrant am I in? If I have a y value of -5. I need someone to say it with
2.
quadrant 2? No, not quite. That would be
4.
quadrant 2 has positive x value. Sorry, positive y values.
Oh, yeah. 4.
Would it be 4?
Yes.
Yes, and, or I should say, or 3.
Oh, so
It could be either one of those. We don't know which one at this point. But then I will erase this information. This says cotangent of theta is negative. Alright? So cotangent is what over what? X over y. Okay? We're told that y is negative. So what does that tell me about the sign, SIGN of x? It must be positive. If it was negative, then I'd have a negative over a negative, which would give me a positive, and this would not be true. So x has to be positive. Which quadrant has a positive x and a negative y? Quadrant 4. Positive x, negative y. So now I can go ahead and label everything. The y is -5. The r value is 8. And we can use good old Pythagorean here. 64 minus 25 is 39. Is that going to be positive or negative? Positive. So the x is kicked over to the right. Sure.
I'm probably just slow, but like I'm kind of confused on how you said that so we know the y is negative, but I kind of got lost right there.
Okay. So we started off with -5/8, right?
Yes.
Okay. So that negative is in front doesn't really help us out. Doesn't tell us which one of those is negative. So what we could do is we could write that as -5/8, or we could write it as +5 over -8. Okay. Those are all equally valid because a negative divided by a positive would give us a negative number. Positive divided by a negative number would give us a negative number. One thing we can't do is we can't say it's not -5 over -8. It's definitely not that. They're not definitely both not negative. Okay? It's either the numerator or the denominator. Now yesterday I said r is always positive.
I get that part, but like you went to like I didn't see like
You're talking about this middle part right here?
yeah.
Okay, sure.
Because I know that.
That's not a problem. We did kind of fly through that part. So based on that, we know since r was positive, we know that y is negative. Okay?
Wait. The
Since-
r was positive, the y is negative, yes.
Okay. And so then when I wrote, instead of writing cotangent of theta is less than 0, I wrote x over y is less than 0.
Yes.
Since cotangent of theta is going to give me the ratio of x over y.
Oh, and then the y has to be negative.
Y is basically negative because of that previous point. And then the question is, what is the sign, plus or minus, of x
It has to be positive to keep that negative.
in order to keep this whole ratio negative?
Okay, sorry, man, I was thinking second grade.
Nope. I know. Well, I am doing a lot of verbal stuff here, and it's hard to kind of keep track of. I agree. Other questions? Once we know this, I'm pretty confident y'all can plug them into tangent secant. Yes?
Yeah.
Okay. Great. So to sum up, we talked about sine, cosine, tangent with all the new values. We talked about how to determine the quadrant that an angle is going to be in based on that information. It's kind of fun stuff. If you haven't tried this, look up additional topics in Trig or whatever. I can't think it's a section in Alex if you're looking for easy topics. All right. Tomorrow's got it scheduled as a work day. I think more than half of you don't need it, but I promise you, so I'll keep it for you there. So you've got 45 minutes to work on the academic subject of your choice. Nick's doing the happy dance. All right, as I'm sure all the rest of you are. All right, kill it.